Hello and welcome to the 15th lecture, MD potential parameters. So far, we have been discussing setting up and visualization of MD. Previously, we have shown you some software regarding MD simulation visualization. And in this lecture, we'll talk about MD simulation potential parameters. These are some examples from OV2 and VMD, like how to visualize your system. And as of now, you should have an idea of MD simulation. It has three critical elements. One is a structure file that we have discussed. One is the visualization, that you will visualize the system by using which approaches. Now, we have also told you that in the software platform or package, there are packages of potential parameters that we have already discussed. Now, where do you get those potential parameters? The answer is whether you can build those parameters or you use some already determined parameters, a set of parameters in your system. So it is really easy to use some already pre-built set of parameters in your system if it is available for your particular scenario. If it is not, you may have to build it on your own according to the literature. Sometimes these potential parameters are available from the databases, for example, through IPR or WebFF, some popular repositories. Sometimes, just like structures, you can obtain them through specific research groups, which particularly engage in developing potential parameters for particular systems. For examples, if you go through this database, IPR, then you can find that there are several pre-built potential parameter sets for alloys, compounds, and also fictional potentials that have not been validated by experiments, but they have developed them according to the theoretical ground. So there are tons of resources in terms of potential parameters, but which one to use here? The answer is it depends. You have to go through the literature review. Like, let's say you want to simulate system A, there is not any resource or literature on system A, then you have to go through the related systems that are particularly associated with system A, and you have to get an idea on what parameters are actually relevant to this system or might be realistic to use on your system. So you have to really consider experimental parameters. Sometimes you have to tweak some parameters of some pre-built potentials according to your particular problem. And you have to keep in mind that you just cannot plug and play in terms of using potential parameters, because a single potential is not good for everything. If you go through the previous lectures on potential parameters, you can get an idea that sometimes in a potential parameter set, only atom-to-atom interaction are taken into consideration. Sometimes electron density is taken into consideration. Sometimes bonded and non-bonded interactions are taken into consideration. Sometimes reactions are taken into consideration. But a single potential is not parameterized for all the systems. Some, even for biomolecular systems, some systems work good for proteins, some work well for membrane systems. But a single system, a single force field is not good or well parameterized for every system. So that's why you have to think really critically about selecting your force field parameters when you are trying to run a simulation. So in the next lecture, we'll show you how to actually run an MD simulation in LAMMPS.